Dear students, I hope you are all well and enjoying online classes. Last week, in the chapter Carbon and its Compounds, we discussed about some properties of carbon and the structure of diamond. Today, we start with the structure of graphite. In graphite, each carbon atom is linked with three other carbon atoms. This forms the basic unit of the structure of graphite. This basic unit repeats itself and arranges itself a hexagonal layered network. Okay, as diamond is octahedral layered, is graphite is hexagonal. There is a weak force of attraction between the layers. Okay, so if you see diagrammatic representation of a very small part of graphite structure, so you can see that three you can see here that each carbon atom is linked with three other carbon atoms. Okay, if it is one two three, okay, it is with attached with other three, like this. So some physical properties of graphite are: graphite is soft and flaky, it is a grayish black and luster crystalline solid, it is insoluble in most solvents. Its density varies from 2.09 to 2.3 gram per centimeter cube. It is the most stable allotropic forms of carbon. It is good conductor of heat and electricity, as well as electricity you can say. Okay, as we know that diamond is poor conductor of electricity. It burns in air at 800 degrees centigrade to form carbon dioxide. So there are some uses of this graphite also, that it is used as an electrode in dry cells. Okay, in physics you have read about it. It is mixed with clay and used as the lead in pencils because it is soft, flaky, and grayish black. Okay, so you can see now you understand also that this part is mainly made up of this lead or graphite. Okay, graphite used as pencil lead. It is used as lubricant in machines to reduce friction between machine parts. Okay, it is used in nuclear reactor also as a moderator to slow down the speed or control the speed of neutrons. It is used for making pigments, polishes, and paints also. So this is grace plus lustrous graphite. Now we talk about the third form. This is Fullerenes. Fullerenes are a form of carbon consisting of a series of carbon atoms arranged to form a hollow cage-like spherical molecule or cylinder. The number of carbon atoms that make up a fullerene can vary from 30 to 900. Fullerenes can be found in the form of hollow spheres known as Buckyballs. You can see figure here also. Okay, in this form, this structure is formed. Fullerenes may also be cylindrical and then called carbon nanotubes also. So if you see, if it is found in cylindrical form like that, okay, so it is known as carbon nanotubes. So some physical properties of it: it is found in nature in small quantities. They can be found in soot, interstellar dust, in the spaces between the stars, and geological formations on the earth. They are soluble in many solvents. So some uses of it: fullerenes are used as insulators and they are used as catalysts also. They are used as semiconductors in computers and flat screens, TV. Some you can say that fullerenes are used as superconductors. So now some questions for you also. Observe the figures and answer the questions. First, identify the substances from the diagrammatic representation of their structure as shown in figures. Okay, ABC. If you say, we already read about it, it is first structure is diamond. Okay, last week we read, and this structure is of graphite, and this is for Bucky balls. Let's check one again. Bucky balls. Okay, this was right. Next question is, which of these substances is used as lubricant? So we read it already that uh, because it is very soft, so graphite is used as lubricant. Which of these substances is soluble? So buckyballs is soluble because it is a effluence and it is soluble in many substances. Explain the term allotropy. Okay, in last chapter, in sorry last class we read about the allotropy. Okay, the allotropy is the existence of an element in two or more forms in the same physical state. Okay, so this is known as allotropy, and the different forms of element are known as allotropic forms or allotropes. So these are the answers of these questions which we read till now. So students, in next class now we will be read about amorphous forms of carbon. Okay, we read about three crystalline forms: diamond, graphite, and fluorescence. Okay, now we read about the amorphous forms of carbon in next class. Till here, if you have any confusion, you can ask to me anytime. Thank you.